constrained optimization question, right? You're trying to find the maximum and minimum of a multivariable function under some constraints, right? And we name the objective function as fxyz, right? And the constraint, the left side of the constraint, as g xyz. And by when I say left side of the constraint, I mean the constraint should always be in the form of some function equals the constant. Okay, so there are some cases where variables are in both sides. In that case, you have to move all the variables to one side so that the equation looks like some function equals the constant, right? So once you have it in this form, any constraint optimization question can be solved by the Lagrange multiplier, which is gradient of f equals to lambda times gradient of g, which means we have to calculate gradient of f. Gradient of f will be differentiating this by x gives you yz, differentiating it by y gives you xz. Is that okay, or should I explain why you get xz? You see it? You want to know? So if you differentiate xyz by y, partial derivative with respect to y, x and z, the other variables are considered as constant. So constant multiples can be brought outside the derivative, right? So that means you have xz times derivative of y with respect to y, but what's the derivative of y with respect to y? It's just 1, right? So that's why you just get xz. So doing that, you get xz. So if you differentiate by z, what do you get? If you differentiate this by z, you get xy. So that's going to be your gradient of f. Now gradient of g would be differentiating this by x. Since these are considered as constants when you differentiate by x, you get 2x. And if you differentiate this by y, you get 8y, and then this by z, you get 8z.
Oh, sure.
And therefore, the equation that you end up getting by the Lagrange multiplier is going to be yz, xz, xy equals to lambda times 2x, 8y, 8z. Which means you have three equations really. You have yz equals to 2 lambda x, xz equals to 8 lambda y, and then you have xy equals to 8 lambda z. Okay. And I obtained these by simply multiplying lambda to each one of these components and setting them equal, right? So 2x times lambda is 2 lambda x. Usually you put the constant in front, right? So put it front, and since that matches with yz, I can say yz is equal to 2 lambda x. And so on and so on. That's what I do. Now, your goal is to find the values of x, y, z. But we have a problem. We have 4 unknowns here, right? You have x, y, z, and also lambda as unknowns. How many equations do we have here? We have just 3. That's not good. We need another equation. If we have 4 unknowns, I better have 4 equations. So where do I get the 4th equation? Yeah?
The constraint equation?
The constraint will be another equation. Right? So this is the another equation that you want. Okay. All right. So now you have a problem of how are you going to, after putting this in, you have this really challenging equation to solve. and we have to find the x, y, and z from it. Let me see. Is that a good way to do this? Yeah. All right, so it's, I mean, the standard rules of engagement for a system of equations applies here, which means anytime you have system of equations, you always solve for one variable and plug into the other, and then that's how you solve it, right? So that's definitely one way to do it, but there's okay, let's do it that way. Just solve for one variable and plug it into the next one. But after that, let's see if there's a smarter way to do this, okay? All right, so here's my suggestion. I'm just going to solve the very first one by, take a pick. Lambda, x, y, z, which one? Lambda, okay, so let's solve this for lambda. And that's going to give us lambda equals to 2x should be divided to the other side, right? So you get lambda equals to yz over 2x. And once you solve it, you plug it into the other formulas, and what do you get? You get xz equals to 8 times yz over 2x times y. And you also get xy equals to 8 times yz over 2x times z. Okay. And then the last one doesn't change. Now, however, you have to be careful here. We're assuming that when this happens, x is non-zero, right? You can't divide it by 2x unless you're sure that x is non-zero. So x equals to 0 has to be considered separately. If x is 0, what happens is that at least one of y or z is 0, right? So if x is 0 and say y is 0, this is satisfied automatically. But then when x and y are both 0, then z is going to be 0 as well, unless lambda is 0. So you do get a case. All right, so that should be considered separately. Case when x is 0, then that says yz is equal to 0 because x is 0, right? And that splits into two cases, y is 0 or z is 0. Now, if y is 0, then you get 0, 0, 4z squared equals to 9, so you get z squared equals to 9 over 4. So that, but it doesn't matter because if x is 0, so, okay, sorry, let me backtrack a little bit. So if x is 0, then you get these, but in any case, if x is 0, you get 0 times y times z as the value of f, right? So you get 0 as the output, okay? So technically, you could satisfy this equation with lambda equal to 0 if x and y are both 0. This will be true. And you get some non-zero value for z. That has to be taken into account, okay? So, but in that case, the value of f is 0. Now, this Lagrange multiplier is not a guarantee. This is saying that if there is a max or min, then this must be true, not the other way around. having this true doesn't mean that it's a max or min. So we have to keep this value, but be conscious of the possibility that this could be neither max or min, okay? But this should be kept in mind. We'll have to look for other places, okay? All right, but anyways, once you have case x equals to 0, we get f as 0, and that kind of says that in any case, if x equals to 0 or y equals to 0 or z equals to 0, then that just makes f at 0, so that part, yeah, we can safely assume after that computation that everything that happens afterwards, we're assuming that none of the x, y, z are 0. Because if any of them are 0, then we get the 0 value for f. Okay? All right, so how does that help us? Well, now we can cancel the z both sides. 8 divided by 2 is 4, and then multiply x over here, and you get x squared equals to 4y squared. Okay? In the same way, if you cancel the y's and multiply and simplify, I get x squared equals to 4z squared. Okay? And that means both of these can be x squared. So this can further simplify by taking this equation and this equation and plugging in here. 4y squared is x squared, 4z squared is x squared, so we have x squared plus x squared plus x squared equal to 9. Are you following? Do you want a slower calculation? Is that good? All right. Okay, yeah, all right. Good? Okay. So now you have 3x squared equals to 9, which means x squared is 3, so that x is plus or minus square root of 3. Okay. Now what does that mean for y? Well, x squared is 3. If x is plus or minus square root of 3, then x squared is 3. So you have that 4y squared is 3, which means y squared is 3 over 4, which means y is plus minus square root of 3 over 2, because square root of 4 is 2. And the same thing applies for z. 4z squared is x squared, but x squared is 3. So you can say that z squared is 3 over 4, which says that z must be plus or minus square root of 3 over 2. Okay, so the points where this is satisfied are plus minus square root of 3 over 2, plus minus square root of 3 over, sorry, plus minus square root of 3, plus minus square root of 2, plus minus square root of 3 over 2. Now, sometimes when you write these down, this could mean that it's all plus or all minus, but here that requirement is not there. So you could have positive for the x value, but negative for the y value. So they're actually, this is 2 times 2 times 2, so there are 8 possible points, 8 points of solutions. Yes, you have a question.
So wait, you go from 4y squared equals 3 to y squared equals 3 over 4 to y equals plus or minus square root of 3 over 2. How did, maybe it's being done like that?
Yeah, if you take the square root of 3, that's square root of 3.
Okay.
But then you also need to take the square root of 4.
Okay, oh yeah.
That's 2.
Yeah.
And anytime you get rid of the square, you have to put plus or minus.
Okay, makes sense. I thought it was like square root of alright. No.
Oh yeah, that's right. It's square root of 3 over 4, but that reduces to like that.
I just thought the whole thing was square root of 3.
Yeah.
That's not why. Alright.
Okay. All right. But in all of these cases, when you multiply them, x times y times z, is going to be either plus or minus, because if all of them are plus, it'll be plus. If you have odd number of minuses, then you're gonna get a minus, otherwise it will be plus. So it's either plus or minus with square root of 3 times square root of 3 over 2 times square root of 3 over 2. So that's f is going to be square root of 3 times square root of 3 is positive 3. So you get 3 radical 3 on top and 4 on the bottom with a plus or minus. Now you just have a competition of these specific values. 0 plus 3 radical 3 over 4 and minus 3 radical 3 over 4. Okay. Now question, among those special values, 0 and these, which is the max?
Plus radical 3.
Yeah, plus 3 radical 3 over 4. What's the min?
Negative 3.
Negative 3 radical 3 over 4. And 0, while there are solutions to this system with x and y being 0 and z being 3 over 2, or plus minus 3 over 2, that solution does exist. That one produces a value which is neither a max or a min. Okay? That's how this works.